Hello, okay, this will be the fifth video about area of the region bounded by two curves. Alright, so now we have two curves, one is a curve, one is a line, right? So how to sketching this type of curve, that's very important, alright? So let's move on with sketching the curve first. So will be between x equals to 4 minus y square and x equals to y minus 2. So x equals to 4 minus y square, as this type of graph is a bit different, right? So, okay, before you're learning conics, so I'm going to teach you another way of sketching this graph. Okay, just sketching, okay, but not very detailed. So you can transform this into y 4 minus x squared, right? So because you are more familiar with this graph, right? You are more familiar with this graph. So usually you will see this graph to be y, right? And x and y. So this is actually negative x squared plus 4, which will be going this way, right? If you look at this, it will be going this way. So it's negative x squared plus 4, right? Plus 4. So what happened, okay, if you see that there is a difference here, is the x here is linear and y here is squared, right? This is x squared and this is y. Right? So you are transformed, you know. So it means that if you are converting this to here, this is y equals to 4 minus x squared. So means that, let's say you have transformed this. You have transformed this into x equals to 4 minus y squared. Of course, the axis here will become y-axis. This will become your x-axis. Alright, now this is not a method, this is just a technique or in your mind. Okay, you try to imagine and teach you. So if you see that this is your y, right? Your y. So doesn't matter this, you look at the x here, So if this is x-axis, this is a positive x-axis, right? This is a negative x-axis, the negative value here. So they are facing to the negative side, you know. Okay, 4 and less. So it means that if you're sketching here, you were getting this to be x, this to be y, of course this will be y, and this will be x-axis. So because this is your x now, right? So it's 4 here, right? 4. So you know there is a 4 here. So of course the graph will be moving this way, right? Moving this way. 4 and less, right? 4 and less. So of course this will be your y-axis, right? So then I have in my mind, after you try for several type of question, you will know that once you see this, you will know this is your curve. Alright? So this is a curve where they're facing y-axis, right? Facing y-axis. Usually this type of graph that facing to the right, that when you solving the question that you have this type of curve where they are open to the right or open to the left, usually your area you will integrate with respect to y. Alright, dy. So, but if you have a curve that open upwards or open downwards, usually you want to find the area we are using to integrate with respect to x. Alright, this is just for helping you, okay? Helping you. So, open right or open left, so we usually will integrate with respect to y. Alright, and for this, we will respect to x. Alright, this is just a hint. Alright, so let's see how to solving this problem here. Alright, okay, let's continuing. I have sketching the graph for this and followed by x equals to y minus 2. So this is a straight line, right? It's a straight line. So now I have to find the x-intercept. X-intercept, definitely y will be 0, right? X-intercept, y is 0, right? You know that. X-intercept, y is 0, so x will be negative 2. So it will be somewhere here, negative 2. So how about the y-intercept, right? Y-intercept will be positive 2 because y-intercept, x will be 0, right? X will be 0. So y will be 2. So it means that they were intersecting at 2. So of course, I also know that this graph intersecting y at intersecting y means intercept y, x will be 0, right? X will be 0. So we try to look at it. 4 minus y squared equals to 0. So you're getting y squared to be 4 and y to be plus minus 2, right? So it means that there is a 2 here and here is a negative 2 here. So of course, from this line, you know that the y-intercept is also 2, right? Because x0, y is 2. So means that the graph is actually drawing, right? This way. So this is the graph between the curve and this line here. So the most important thing now is, where is the region, right? Where is the area of the region that this question mentioned? Bounded by the curve and this line. So of course will be this part here, right? Can you see that? It's between the curve and this line. So this is the region here. So this is the region day 1. So I label this as R. So very important. So I know that one of the intersection point here is 2. Okay, but I don't know what is the value here. Alright, I don't know what is the value here. This point here, point A, but I know point B. So definitely I need simultaneous equation to help me, right? So because now the x value must be the same, right? Intersecting point, the x and the y value will be the same, right? So the x and the y, the value must be the same. So I can say that I can equate x to this x here. So means that 4 minus y square equals to y minus 2. So as I'm solving this, I will getting y square plus y square plus y, negative 6. So factorizing, we're getting y, 2, 3, 6, 2, 3. So this will be positive and this will be negative, right? Because y square, 3y, negative 2y, get positive y. So you're getting two value. One is 2 and the other one is negative 3. Exactly, right? So y is 2. So means that they're intersecting at these 2 points. One is at y equals to 2. The other one is y equals to negative 3, which is slightly below here, okay? Negative 3. So I'm going to write the negative 2 here. Okay, negative 3. So means that they're intersecting at this region here, right? Negative 3. So this region bounded now is facing y, right? That's why I just I'll give you a clue, right? Because they open to the left or open to the right. So this type of graph, usually you will define the area with respect to y, right? With respect to integrate with respect to y. Alright? So, and this also must be a y value, right? Which is bounded between from the graph is bounded from negative, the graph itu ditutup from negative 3 up to 2, right? Negative 3 up to 2. So I have to put here negative 3 up to 2, right? So now for this case, there are no up and down, but they are right and left. Right curve and left curve here. So which one is the right curve? Right and left. So we will take a more positive value of y minus the more negative value here. That's why I said right minus the left, because why? This is more positive compared to this. Alright, the x value here is more positive compared to this, right? Then the right curve here, the right, okay, the right curve. So the right will be this one, okay. I label this as x1, right? X1. So how about the left? Right and left, alright, left. So left will be the line, x2, alright. So means in this case, everything must x in terms of y. So I'm going to take x1 minus with x2. Why? Because I have said that for when you integrate with respect to y, you have to take right minus the left curve. So the right, which is 4 minus y square, 4 minus y square minus with y minus 2. Okay, x1 minus x2 here. So, okay, after you have defined the area, then the following you should be correct, right? Okay, before that I will simplify negative 3 from 2. So rearrange this, you have negative y to the power of 2, right? Negative y to the power of 2, negative y, 4, negative, negative, positive 6, positive 2. So 4 plus 2, positive 6 dy. Right? So then I integrating this, I have negative y cubed over 3, negative y cubed over 3, minus with y squared over 2, plus with 6y. And from the region y equals to negative 3 equals to y equals to 2. So evaluate as usual, and until you have expert in evaluating this, you just have to substitute, okay, show that what you are doing, negative 8 over 3, right, 2 to the power of 3, 8 over 3, minus with 2 to 4, 4 over 2, plus with 12, right, minus away, negative 3, right, so negative 3 to the power of 3 over 3, negative 3 to the power of 2 over 2, plus with 6, negative 3. Alright, you just write down and you can using calculator calculate which will be faster. Alright, for the first part here, I will getting 22 over 3. And for the second part here, I will getting negative 27 over 2, which give me 22 plus 27. Okay, 22 over 3. Right, 22 over 3 plus with 22 over 3 plus with 27 over 2. So which give me 125 over 6 unit square, right? Getting unit square. Alright, we're getting 125 over 6. So that's all for these examples. We will go for the next example in the same video. Right, okay, let's go for the second example of this video. Find the area of the region bounded by these two curves. Right, so it's between two parabola. Alright, just now it's between a parabola and a straight line. So never mind. So we have to try to sketching this first, as this one easy. So as I teach you before, that you can try to imagine that if you have y squared to equals to x, you can try to do it as transform it as x and this one to be y, right? Or is y equals to x squared. As you know, the graph for y equals to x squared will be facing upwards, right? Yes, facing upwards. So it will be y and here will be your x-axis, right? So, but now, if you have already changed, means that you have transformed the x become y squared, the x become y, definitely the x-axis now is no longer x, is y-axis, and this will become your x-axis, right? So they were facing, can you see that? The arrow, they're facing there, right? So it means that, okay, you see how I sketch here. So I have y and I have x here. Can you see? The arrow is here, right? They are facing with the arrow. So then I know that it will be here, right? This will be the graph. So this is, will be the graph for x equals to y squared, right? Okay, done with this curve, and let's move on with this. Alright, so but usually I will prefer students to sketch, before they sketch, they try to find whether is these two curves have intersecting or not. Is these two curves intersecting? So how to know that whether these two curves are actually intersecting or not? Means that did they meet each other, or they just go through, okay, or they forever won't meet, or they will meet somewhere here. So we have to find. Before I sketch, okay, I will do some checking first whether these two will be intersecting or not. So it means 2y squared equals to x plus 4 and y squared equals to x, right? So I solve the simultaneous equation first to verify whether these two graphs intersecting or not. So okay, I'm solving. So x is y squared. So x is y squared plus 4. I find the value of y here because I know that this graph now is open to the right, open to the right. So either of the graph is a parabola that open to the right, I will consider integrate dy, right? dy. So means that the y value is more important in this case here. So that's why I solving to get the value of y here. So okay, let's see. Y square minus 2y square minus y square, I have y square equals to 4, which gives me y to be plus minus 2, right? Means they are intersecting because you have real values here. You have two different real roots, all right? You have two different real roots. So means that the graph is intersecting. So how was it before that? Okay, now I know y is equals to plus minus 2, all right? So I be ready. I know that they were intersecting at negative 2 and 2, right? So, okay, before that, let's see how to sketching this graph here. So usually I will do it this way. 2y square equals to x plus 4, and I convert this to be x equals to 2y square minus 4, right? X is 2y square minus 4, y square. So I try to imagine in a way that x is y, and the y here is x square, right? 2x square minus 4, yes or no? Oh, 2x square minus 4 is very easy for you, right? 2x square minus 4, negative 4. So this is the graph. So this is your x and this is your y-axis, right? This is the graph 2x square minus 4. But in reality is the y has already become x and the y square is already become x square. So of course you have to transform this between y and this one into x, right? Now this is just an imagine. This is not a right way to sketching the graph of parabola. This is just a way for letting you to think fastly to sketching the graph. Okay, it's a techniques. All right, so facing x, can you see the arrow is there facing the positive x? So it means that from negative 4 here, I know from negative 4 here, so the graph is going this way, right? They are going this way and they are intersecting here, and this graph also going this way and intersect somewhere here. So it's like something like an eclipse, right? So you see that there is a x equals to 2y square minus 4, right? If you see that minus 4, so I know that the x-axis, so they were going this way. And how I know they're intersecting? Because just now after I solve simultaneous, I get the value of positive and negative 2, right? So means that for this point A and this point B, if you draw to the y-axis here, you are getting negative 2, right? You are getting negative 2, and the y you are getting 2, right? You are getting 2 here. So, and now I know that the area of the region bounded between these two curves, which is this one. Very beautiful here, right? Very like a boomerang like that. Okay, now. So how to calculate the area of this region? So the same thing, I have to know the right curve and the left curve, because now it's integrate with respect to y. So if you said integrate with respect to x dx, so I will say top and bottom, right? Now it's right and left. So now which one is the right curve? Which one is right? This one, right? This one. This is on the right and left. So right, so this is your right. So it means x equals to y squared. I put this as x1 here, all right? To tell me that this is the right. So, and for this, I write x as a subject. So x2 equals to 2y squared minus 4, right? 2y squared minus 4, x2, because it's on the left, right? So now later, if I integrate, I know that I need to take x1 minus x2. You must make sure that you are doing the right thing, okay? By viewing the graph here. So, okay. Now I have to integrate and showing you. All right. Okay. So now I have to find the area. After I'm talking so long, it's because I want to define a correct integral for this region here. So this region, if you see that this region is closed, enclosed, ditutup, bounded by these two curves from -2 up to 2. So it's from -2 up to 2. And who is on the right? x1, right? Which is y squared. So I'm writing y squared minus the one that on the left is dy. On the left is 2y squared minus 4, right? This is on the left, right? This curve, the name is x equals to 2y squared minus 4. So, okay, that's all, very easy. You just integrate this. So then you have integrate from -2 up to 2. Y squared minus 2y squared. You have negative y squared, right? Am I correct? Y squared minus y, negative y squared, negative, positive 4 dy. So integrate this, you have negative y cubed over 3 plus bit 4y from -2 up to 2. So substitute inside, you have negative 8 over 3 plus bit 4 times 2, 8, right? Minus with negative, don't forget negative 2 to the power of 3. Negative 2 to the power of 3 is negative 8, so you get positive 8 here, right? You get it positive 8 here, and 4 times -2. 4 times -2, you have -8. Alright, let's see what you get. So as I see that this you have 8, negative, positive, negative, positive 8. So means 8 plus 8, you have 16. 16 minus with 8 over 3. Minus with 8 over 3, which give you 16 minus with 8, 2, 8, 16 over 3, right? Okay, let's evaluate this. 16 minus 16 over 3, right? So which give you 32 over 3, right? You will get 32 over 3 unit square. Alright, so I have shown you how to find the area between two curves here. So, okay, you try to view all the video from the area between two curves, part 1 up to the video part 5. Alright, see you.